on number 9. This is asking us to work with piecewise functions. And if I were to graph each piece over the domain, okay, if I think of the domain, it's what x values are in my function, and sometimes it's easier to graph it first and then describe the domain. So in the first part of this function, I have the x values are less than 3. So I'm going to pick some x values that are less than 3. I'm actually going to pick -3 as well, because I do want to know an endpoint for this. It would just end up being an open circle because I don't see a negative there. So in this first part, and this would be the absolute value of x plus 3, and then plus 1. So if I pick -3, I would plug in -3 plus 3 is 0, and the absolute value of 0 is 0, plus 1 is 1. Then I might pick -4. I'm picking numbers less than -3. -4 plus 3 is -1. With the absolute value of that, it's +1, plus 1 is 2. Maybe I pick -5. -5 plus 3 is -2. Absolute value of -2 is 2, plus 1 is 3. And if I plot those points, I have -5, +3, that's up about here, -4, and 2, and -3, 1. And this is where I'm going to have an open circle. And I can continue to pick -6, -7, -8, but I know that because it's an absolute value, this is going to make part of a line or array. And it's going to start at -3 with an open dot there and go upward to the left. Then I have from -3 to 2, I have the function x plus 1. So I do want to include -3 and 2 and maybe a couple values in between. If I put -3 in the function, -3 plus 1 would be -2. How about I pick 1? That's between -3 and 2. 1 plus 1 is 2. -2 plus 1 is 3. I know that these points will make a straight line because this is linear. So if I plot these points, at -3, I will have a solid point. At -3, -2, just down here. And then I have a point at 1, up 2, and at 2, up 3. Now, here at 2, this is going to be an open circle. So over 2, up 3, I'm going to have an open circle here, and then I'm going to connect these. For anything that's greater than 2 and equal to 2, I'm going to have the function x squared. So I'm going to take x squared, pick some values. I want values that are greater than and equal to 2. So I'm going to pick 2. 2 squared is 4. I'm going to pick 3. 3 squared is 9. I'm going to stop there. But at 2, I'm going to have 2, 4 as being a point, and then 3, 9, that'd be way up here. So this is kind of going to look like this. So this is my piecewise function. The domain, if I look at my x values, and if I kind of collapse everything on the x-axis, I'm going to have x values go from -infinity all the way to positive infinity. I can put 10 in here. I can say 10 squared is 100, and I can go over 10 up 100. So if I were to say that the domain is all real numbers, any number I pick will give me a y value. Part C, the x-intercept. If I look on the x-axis, I have an x-intercept at -1, so -1, 0. The y-intercept is at +1. Sorry about that. So over 0, up 1. And the range, now the range starts at, my lowest value is -2, right here. And it goes up and up and up and up and up to infinity. So my range starts at -2. It includes -2, and it goes to infinity. And the last page, we have some transformations. What